Today we are going to look at a very short demo of test analytics, which uses the feed from the historical data of the test cases, the test defects, and arrive at a defect prediction model. We'll leverage our eConvergence platform to collect data from various ALM sources and defect management repositories, and then apply machine learning's algorithms to enable this kind of prediction model. Today the use case that we are going to look at is the expected success or failure of a requirement at the release end date. We'll look at historical data related to that nature of requirement, look at various aspects of historical data, what has been the success ratio in the past, the kind of defects that have been found, and predict a reasonable outcome for that towards the end of the release. This is usually done in a 4-step process. Step 1 talks about configuration of the data source. So this configuration of the data source usually talks about two different things. First, the training algorithm, which actually talks about training the algorithm to look at those predictions, and second, the prediction itself, or the application of that query over the data and then predict a reasonable outcome. So towards in this first step, we look at different ways of configuration of that query, which is both for training and the predictions and reading the predictions out of those queries. So eConvergence gives us that capability to define those algorithms, refine those algorithms, and then create a very reasonable outcome-based prediction. Step 2 talks about creating instance of machine learning algorithm. Now there are different algorithms that can be used for machine learning. eConvergence currently subscribes to scikit-learn for this, which exposes some of the ready-made algorithms and then overlay machine learning on it. So these are the parameters which gets configured. There are different parameters. So the one bug fix, prediction, regression, success, and there are different ways. In terms of step 3, we look at create scheduling around it in terms of how we schedule those training jobs and schedule those prediction processes. So what you see on the screen is the different schedulers, the different algorithm that they are going to use for querying and training. So it crunches a lot of data to train itself in terms of what has happened historically, and using that as an information to start creating a prediction model. Once these jobs have been configured, once these jobs have been trained enough with the right set of data, it starts creating right set of outcome in the end. So in the use case that we have chosen to look at the success of the requirement towards the end of the release, even before we have started testing. So that is what we are configuring. Now if you look at the how the predicted values are shown in the end, and how does it flag up the hotspots. So after the query configuration, after all that data that is actually learned through, we run that on a particular release on a particular requirement, and it gives you a reasonable outcome. So if you go to the analytics dashboard of eConvergence, you pick up a particular release, a particular requirement on which this analytics have been run, and then it will give you a very particular view of what those potential hotspots could be. Obviously, for this to work with great precision, it requires a lot of training to the machine learning algorithm itself, which is what we have looked at the earlier stages. So if you look at this particular section and the way algorithms have run, it using the historical data of this kind of change, it has given hotspots in terms of whether it's a test risk associated, whether these kind of requirements are usually late on the design or they have high defect failure rate. Now all of this information becomes readily handy for us to prepare better at the stage of test preparation itself. Thank you.